Morning, everyone. Welcome to our webinar. Great to have you with us today. So our webinar is Cutting Business Energy Costs, Smarter Tariffs and Technology and Lower Bills. We've got an exciting packed agenda for you today. Our webinar will run for about 45 minutes. There'll be about 30 to 35 minutes of presentations, and then there'll be the chance for Q&A at the end. So my name's David Shealy. I'm Director of the Energy Innovation Agency. Just before we hand over to our first session and our first presenters, I just wanted to explain a little bit about the Energy Innovation Agency. So the Energy Innovation Agency was created in Greater Manchester in 2021. We're a public-private partnership created to help accelerate the carbon neutral economy and the clean energy transition in Greater Manchester. And effectively how we do that is we work with energy innovators and organisations like buyers or end users with energy challenges. And we break down what the innovator's aiming to do and the innovations, what challenges it's looking to solve. We look at the challenges from the end users or the buyers, and then we convene the two and create low carbon projects that both help increase deployment and commercialization of effective low carbon innovations, as well as obviously helping with sustainability targets, cutting costs for organizations and helping them decarbonize at the same time. So just going through the agenda then briefly, just to cover all what we'll be doing. So I'm going to hand over in a minute to my colleague Kevin Aisbett, who's leading a fireside chat with two organisations in Greater Manchester. We have Kratos Analytical as a large manufacturing business, and then we also have Salford District Council in the public sector. And that's really a really interesting section to hear. That chat will be hearing from some real insights from both organisations around how they're tackling energy and their sustainability strategies, and how important technology is in helping to deliver successful strategies. Then we'll hear from a couple of innovators. We have Q Energy, who'll be talking about their smart energy tariffs and battery systems, and we'll also be hearing from EnviroHeat, who have smart hot water cylinder and systems as well. And then finally, at the end, there'll be sort of 10 minutes available for questions and answers. If you do have any questions, please feel free to put them into the chat. We'll try and pick those up and raise those at the end. And then when we get to the Q&A section at the end, like I say, after about 30 minutes or so, we'll bring our presenters back to answer that Q&A, and I'll do a wrap up at the end. And then there'll be a recording of this available afterwards. So if you'd like to, find out more afterwards, we'll share that. Okay, so without further ado, I'm going to hand over to Kevin Aisbett and the fireside chat. Thank you very much.
I'm the Innovation Project Manager at the Energy Innovation Agency, and we're just going to take you through and go through our fireside chat with Hayley and Rahil. Just before we get into that part of the webinar, can I just ask Hayley to introduce herself?
Yep, so hi, I'm Hayley Nixon. I work at Salford City Council. I am our strategic lead for zero carbon delivery, so looking at everything to do with our estates, how we operate, and achieving our carbon neutrality target by 2038 across our operations.
Great, thanks Hayley. And Rahil?
My name is Rahil Amin. I work at Kratos Analytical Limited, based in Manchester, Old Trafford. My apologies. And I look after the supply development manager role, and also the facilities management over 2 sites now. And I'm part of the Green Directive for the corporate strategy at Kratos.
Great, thanks Rahil. Yeah, so really just the first question, maybe to start with yourself, Rahil. What do you feel is the importance of having an energy strategy as an organisation?
It's mainly twofold. One, we're trying to reduce our carbon emissions as part of our corporate strategy overall. And secondly, it's actually engaging with the actual employees to introduce that and see how it actually benefits not just the company but also themselves as well, and to educate them individually in terms of, for example, recycling, reducing our emissions, etc. And it's been a bit of a journey, but it's been quite informative, I think, for everybody.
Great, thanks, Royal. And for yourself, Hayley?
Yeah, in terms of importance of an energy strategy, there's a number of benefits from an operational point of view, looking at energy efficiency measures, reducing costs, reducing carbon, but also looking to the future in terms of, fluctuating prices and issues with the grid and supply of energy, and looking at how we can operate in the best way and make our operations as efficient as possible for reducing costs for our residents and members of the public, so we can improve our services.
Yeah, just on that, what you mentioned there, Hayley, about the energy side of things. So where do you feel sort of smart energy tariffs need to be considered as part of that? Well, not strategy, but just in that day-to-day activity.
Yeah, it's part of the mix of things that you can look at with regards to an energy strategy. So, there are sort of smart tariffs out there where there's cheaper prices at different times of the day. And if you can look at your operations and see if there's things that can be done to align or change the way that, say, operations are happening, or when things are happening within your organisation that can take advantage of those smart tariffs, then that's, great. And looking at the ways that sort of whatever equipment or machinery that you've got and when that's operating, and if it's operating at the right times of day as well, to try and sort of smooth those peaks of energy demand into cheaper tariff times, and then that's a really good starting point.
Great. And any thoughts, Rahel?
No, I completely agree with Hayley. We have instruments which are basically the main consumers within the actual company, so they run 24/7. But there are other operations within the group. For example, the baking of instrumentation, which obviously high energy usage, which we're now trying to separate out as well, for more efficient times, into the smart tariffs as well, and utilising it, to the best advantage, really.
Mm-hmm. Great. And just continue with yourself, Royal. And what do you feel is the importance of low carbon technology as part of all, that overall strategy and the day-to-day operations of a business and an organisation?
I think it's extremely important, and I think in terms of the overall strategy and as well, most people just look at, for example, just the energy aspects of it as well, but it's also in the producing of the actual parts. For example, we make scientific instruments, and a lot of it comes in, for example, cardboard packaging, but that needs to be disposed of or reused where possible. And there's other alternatives. For example, instead of using single-use plastics, we've started to use reusable crates. We have a lot of external customers from abroad, and we do quite a lot of recyclable, not so much reusable parts as a part of that as well. So that's been a big part of it as well. And again, it's just convincing the actual corporation that you've got to invest in terms of to reduce the carbon footprint that we've actually created, but also it actually is more efficient, and it works beneficial for everybody. Sometimes it's not going to be advantageous straight away, but the long-term strategy is what we're looking at now as well, not just short-term goals.
Yeah, I'll come back to that as well, because I do want to maybe ask a question around what do you think, what technology is needed in the future. But if I could ask Hayley just to give your thoughts on that, that question around the importance of low carbon technologies.
Yeah, I think, obviously we, as an organisation, and we have varied buildings across our estate. We have over 100 buildings ranging from sort of, the civic centre and leisure centres to crematoria. So we have really wide-ranging technology and assets across all those estates, and making sure that they're working and maintained well is a really important step. But then when it comes to having a pipeline and a view of when those items are up for renewal and being prepared for those, because obviously as technology changes, as there's new advancements in different technology, making sure that we're on the front foot to be able to take advantage of those and reduce our emissions further, and how you use and take a whole building approach. So obviously there's any energy efficiency measures that you can undertake, renewable tariffs for your energy supply, and then moving on to sort of solar PV or battery storage, looking at how that can support other activities such as electric vehicle fleet is important for us, and then moving on to sort of decarbonising the heat from those buildings when the opportunity arises, either from sort of air source heat pump or heat networks if that's an opportunity. It's taking that staged and measured approach that I think is really important for us, and having that overall view of when those things need to happen, and like you say, the investment, and having that sort of be at the forefront of everyone's mind that is a long-term investment that will be good overall in the long run, but there is an upfront capital cost to some of those renewal activities.
Yeah, and just picking up on that question around, what technologies needed in the future, you mentioned battery technology, Haley, and I know from personal experience that, the demand in the future is going to be for, better quality, or looking at the materials that are in, within a battery, but also the duration and being able to store energy longer and deploy it longer. I mean, have you any thoughts on that? And not just specifically batteries, but just technology in general?
Yeah, I mean, like I say, sort of for us, we have assets and we have a lot of solar PV on our estate. So for us, looking at how we can utilise and maximise the benefit of that solar PV on our own estate, whether that be through batteries or charging electric vehicles. I know obviously there's opportunities in the future with regards to vehicle to grid charging. So where we have a large fleet, looking into what the opportunities are there for us to sort of be more self-reliant and utilise that technology. But then, on the heating side, there hopefully will be advancements with sort of heat pumps and higher temperature heat pumps rather than the lower temperature ones that we've used previously. Heat networks is a really interesting concept that's coming forward at the minute in Greater Manchester, and the opportunity that might come forward through those. And then there's also things working with, say, Electricity North West around flexibility services. So where we have large amounts of assets, is there something that we can do with the electricity distribution network to work with them to get some value out of that as well? So yeah, there's lots of potential coming down the line, I feel that.
Yeah, great, thanks, Haley. In Rahil, as a tech company, and I know that you have applications on things like batteries and other technology. I mean, I'd be interested to know, in terms of your own sort of internal R&D, do you think the rest of the technologies are sort of keeping up with the pace of what your business is trying to do, and do you need to hold back a little bit to sort of take into account that maybe some of these products or services are not quite there yet?
Well, it's quite strange because we actually manufacture instruments, X-ray instruments, which most companies now use for battery technology. So we're literally at the very forefront of battery technology development. So we're sending out instruments across the world, mainly for electric vehicle charging and what the constituents are made out of. So in terms of a strategy, we've just installed last year 1,369 solar panels on our factory, which is generating 600 kilowatts of potential power. What we didn't actually go down the route of at this stage was actually putting in batteries, even though we run 24/7.
Yeah.
Because we don't believe the battery technology at the moment is going to be worthwhile for the investment that we would have to replace in maybe 3 or 4 years' time.
Yeah.
So that is a concern. The rate of change of battery technology is huge, but until we get to the solid state and everything else, it's still a concern for us in terms of finding better alternatives for the moment for our low carbon strategy itself.
Yeah, I think specifically on batteries, that seems to be the opinion, isn't it? Is we can put the solar on the roof, but maybe the battery technology isn't quite, as you say, isn't quite there yet. But as well, I suppose one of the things around the energy tariffs, if you're using that excess energy, and maybe what Haley touched upon, on the heat networks, is, well, how can we sort of sleeve that excess energy across an estate of buildings, or between buildings, that, for example, with with Salford District Council. Yeah, so it's a very interesting subject. I suppose the final question I had was, knowing what you do about the Energy Innovation Agency, how do you feel we can help support not only what you're trying to do as a council and as a tech business, but just to help organisations in general? Again, maybe that question first to yourself, Rahil.
So it's been quite an interesting journey, but it's been very informative. I think one of the things that we've learned is the different types of technologies and the support that you, for example, the energy innovation can give, and just the actual knowledge of it as well. It's still a relatively new subject for, I think, a lot of corporations and for people to actually grasp. Most people just think it's just solar power and that's all there is, and reducing our fossil fuel consumption. But there's an incredible amount that, for example, we've learned on the actual courses that we've attended about the alternatives that you can actually use. And it's not just energy directly, for example, heating and maintenance part of it. It's actually how you use that technology as well. So, for example, we've stopped using a lot of cardboard, and that saved us an awful amount of, for example, waste. So again, that's part of the low carbon, because it just goes back essentially not to be recycled. Not all of it can be recycled. And also they're looking at alternatives as well. So we've just exchanged all our radiators now for different types of heat pumps. So, for example, we had quite a decent summer last year, and had we not thought about it, but we had a zero gas bill for about 4 or 5 months because the PV was able to supply all our requirements.
Yeah.
But one of the things that I think we're struggling, I think, to your previous question, is the infrastructure behind what we actually have is not able to support what we're able to produce. For example, I can't put too much back into the grid because the grid can't handle it in this particular location. I think that's one of the issues that we have. It's the infrastructure.
Yeah.
And I think some of the newer technologies that, for example, that you've mentioned, the heat network would be something that we could develop, and we wouldn't have known about it had we not engaged with yourselves, for example.
Yeah. And yourself, Hayley, any thoughts on that?
Yeah, I think it's that link, isn't it? As an organisation, we're sort of looking for solutions, looking for different ways across our estate and across our operations to be more energy efficient, save carbon, and reach our targets. So it's that link. There's always new technology. There's always new, data-driven solutions, etc., that we can be looking at, and it's those linkages and connections to what's innovative and new, and what's coming through the Energy Innovation Agency can make those links for us and connect us to what's happening, and any pilot opportunities or new things that we should be looking at.
That's great. Yeah, I mean, that's the end of my questions. I just wondered whether either of you had any more thoughts or any other points that you'd like to make to the audience.
I think from my perspective, I think one thing is very key is the engagement of the people that you work with. So, for example, there's an awful lot of investment when we first put the solar panels in, and there's a lot of hesitancy amongst the actual staff of, why are we spending so much money, etc. So what we did is we put up a touch screen actually in the canteen area, so they can actually see what electricity not only we were generating, but how much CO2 we were actually reducing, and how it was actually impacting us on a day-to-day basis. And that engagement actually, we gave them an open forum, saying, what else could we possibly do? And once they actually saw the engagement and how much money we were actually saving, but also the CO2 reduction, they've got a different outtake on it in terms of how it is benefiting not just the company but themselves as well.
Yeah. And for yourself, Hayley?
I think that's a really good point. For us, we have a really large programme of carbon literacy, so we try and encourage all our staff members to undertake that course so they understand the impact of the choices they're making on a daily basis, both in their personal lives, but also from a work perspective as well, in terms of decisions and things that they're doing as business as usual. But, you know, alongside that, I think it's, like you say, new technology. There's small changes that can be made that have a big impact, and there's always somewhere to start, and that sort of can set you on the right track. And there are new technologies or new, you know, like you say, solar PV going in. Electric vehicles for us was a learning curve as well in terms of operational and how they work differently. So there is a learning aspect and a change in the way that sometimes we have to operate, but it's communicating those benefits, that there are really good benefits for those changes and reasons why we're doing them, and you know, having staff on board and stakeholders engaged is really important in making those projects a success.
Yeah, that's great. Yes, that's the end of the fireside chat. If I can just thank Hayley and Rahil for taking the time, and I thought it was really informative in terms of their experience and their thoughts on, you know, what organisations need to do in terms of their low carbon strategies, and obviously that reference to energy tariffs as well. There will be a Q&A at the end of the webinar, and I'll just now hand over to the next speaker. Thank you.
All right, thanks very much, Kevin. Really interesting to hear from real businesses about their practical experiences, and a great introduction to what I'm going to be speaking about today. My name's Jo Southernwood, and I'm an energy consultant at Q Energy. Q Energy is an award-winning smart services provider based in Manchester. We help businesses to cut their energy and carbon emissions by intelligently managing assets like battery storage, heat pumps, and electric vehicle chargers. And today I'm going to be telling you about our latest innovation, the Smart Battery Tariff, and I'll explain how you can use a smart tariff alongside battery storage to cut your electricity bills. Now, I'm willing to bet that most of the businesses listening today are on a fixed rate electricity tariff, and perhaps you or your energy manager made that deal several months ago, maybe through an energy broker, maybe through your supplier, but you did some kind of price comparison exercise that was probably based on your previous year's energy consumption. And at the time you made the deal, it was probably the best deal on the market. The thing is, electricity markets are not static. The price of electricity shifts and changes all the time based on things like the balance between supply and demand for energy at different times of day, based on the weather, based on world events. And what that means is the electricity markets are highly volatile. So in practice, that deal that you made 6 months ago probably isn't the best deal anymore. And it's worse than that, because now you're locked into that deal until the contract ends. What it means in practice is that although you're protected if the price of energy rises, it also means that you can't take advantage of any price drops that happen during that contract if the market moves in your favour. Now, at Q Energy, we think there's a better way to buy energy, and it's called a smart battery tariff. So what we've done is we've developed an AI-driven energy trading platform that forecasts your energy consumption and re-optimizes your energy purchasing strategy accordingly in real time. So the platform intelligently responds to pricing signals, and it uses any flexible assets that you might have at your site, like batteries or heat pumps or electric vehicles, to shift demand away from those expensive periods and towards the cheaper periods. Now, by doing that, we can make sure that your electricity bills are lower, and you could expect savings on electricity bills of anywhere up to 25%. And in fact, last year, we signed up a major bank to our smart tariff, and we're predicting that over their 3-year contract, they'll save in the region of £315,000. Now, what we're doing now is we're making that same enterprise-grade platform available to businesses of all sizes. And probably you're wondering how we can possibly make such a bold claim, because after all, energy prices are always on the rise. So I'm going to try to explain that very briefly on the next slide. So the first step is that our AI makes an accurate forecast of your electricity consumption, and we buy electricity in bulk in advance when prices are favourable, and then we re-optimise them using that AI dashboard closer to the time when the energy needs to be used, and we decide if we need to adjust that purchasing strategy. So although, for example, we might buy energy today that you will eventually use in 6 months' time, we actually optimize that strategy and that prediction as we get closer. To give you an analogy, you might know roughly what you're going to be doing 6 months from today, in that you probably know you'll be at work. But you don't know exactly what work you'll be doing on that day until much closer to the time. And we use that exact same principle for buying energy. We buy in advance, and then we refine our predictions as time draws closer. So a month before, we adjust based on how your site is really using energy. Then maybe a week before, we adjust again based on a long-range weather forecast, and we do the same again a day before, when we have a much clearer picture of how much energy you'll need and when you'll need it the following day. So all those predictions and adjustments mean that we can make sure we buy the right amount of energy at the right time and at the right price. The second thing we do is we install a capex-free battery at your site. So the battery doesn't cost you anything, but it charges every day when energy is cheap, and it discharges during those peak times, meaning that we can avoid buying electricity when prices are high and when it has a very high carbon emission associated with it. Now, if you have solar PV at your site, the picture is even better, because we can store any excess solar generation in the afternoons in the battery, and then we can use it on site later, again to avoid those peak times instead of exporting it to the grid. Finally, what we do is we provide you a guarantee on the level of saving you can expect. So that guaranteed saving depends on the site, and of course we do need to recover the cost of the battery from the saving, but it's often around 2p a kilowatt hour cheaper than the best available fixed rate. And if there are additional savings on top of that, we share them with you. Now, the best way to describe our shared savings approach is with a case study. So one client came to us and they said that the best fixed rate that they had been offered was 21.2p a kilowatt hour. When we profiled their site, we found we were able to guarantee them a rate that was 2p a kilowatt hour cheaper, so 19.2p per kilowatt hour, and whatever happens, that's the most that they'd pay. And that guarantee immediately gives them an annual saving of just under £68,000 a year. But as an example, we often do better than our guaranteed rate. So let's say, for example, we actually achieved a rate of 17.5p a kilowatt hour. What we do is we take a small service fee to cover the cost of the platform, but then any additional savings over and above that, we share with the client. Now, in this particular case, Q Energy retained 80% of the savings, with the client retaining 20%, because we took on the upfront cost of the battery. But this does vary on a client by client basis. The key thing is we don't charge a commission like brokers do. Instead, what we do is we share a percentage of those extra savings with you, which means that our interests are aligned with your interests. We earn more money when you save more money. So it's an incentive for us to make sure that we're saving you as much as we possibly can. This particular client is on course for a 10.5% saving on an annual usage of 3.4 gigawatt hours a year. So hopefully that's given you a flavour of what a smart battery tariff is and how it works. If you have any questions, please do feel free to put them in the chat, and I'll do my best to answer them in the Q&A session. But for now, thanks very much for listening, and I'll hand you over to Luke from EnviroHeat.
Hello, everybody. I'm Luke, the Commercial Director of EnviroHeat, a Manchester-based manufacturer of low-carbon heating and hot water technologies. Before I start, thanks very much to the team at Q Energy for that presentation. I'm now going to follow on in a similar vein with my kind of clickbaity titled, "Your building already has a battery, it's full of water." Usually I start these things by saying a quick show of hands. How many of you think your building has an energy management system and an energy storage system? And usually no one puts their hands up, or maybe there's one person that does. And I say, oh, here's the twist. It already does. Aha, it's your hot water. Most organizations spend huge amounts of time optimizing lighting, ventilation, air conditioning, solar panels, EV car charging. But the biggest energy system we all know is heating and hot water. It's often running on very simplistic controls, not really optimized. And today I'm going to show how a simple hot water cylinder can become one of the cheapest and smartest energy storage systems in your building. It can slash your bills, cut carbon, and even help balance the national grid. Now, heating and hot water in commercial buildings, if it's hotels, manufacturing sites, offices, schools, public buildings, heating and hot water often account for up to 70% of energy use. It's a large area to tackle. And if we look specifically inside a plant room, most commercial buildings will often have a plant room with lots of equipment inside, including hot water cylinders. These are metal vessels that store hot water for use later, and they're often powered by an external heat source. Yet most hot water cylinders are treated like simple tin cans. They heat water, they try to maintain a set temperature, and they leak energy. They don't respond to tariffs, they don't optimize demand, they waste renewable energy that could otherwise be stored. And this is the kind of status quo. If we take a look here, this is a bog standard 300 litre cylinder, the outside of it. So we've got all sorts of pipework that's on the front of it. We've got a immersion element, we've got a temperature sensor, and we've got some controls for the primary heat source that are integrated onto it. If we look at the inside of it, here's what the kind of internals look like, which is a coil at the bottom. That's usually powered by your gas boiler or your air source heat pump. The immersion element, as I mentioned before, and then the rest of this is, volume to be heated of water. And then on this right-hand side, we've got a thermodynamic sort of graphic about what happens inside the cylinder over a period of time. Now, hot water storage is designed to be stored to be used later. And over time, heat separates inside a cylinder. When you're not using it, which is the majority of the time, heat stratifies. It just means it rises to the top. Leaks out of the heat energy leaks out the top of the cylinder, and the bottom starts to cool. Then when you draw hot water off for your processes, cold water enters the bottom, that fills up, and then it triggers the thermostat to kick in your primary heat source, heating the whole thing back up again. And there are several missed opportunities with this. It's not really the most efficient way of doing things to have this heating, then cooling, then heating, then cooling, and not really using the full potential of the cylinder. The next thing is, if your business already has renewable power, a sensible idea is to look at, if we're generating, let's say, via PV energy, divert that into your hot water. Great. It's electricity, goes straight into the electrically powered immersion element, and then that heats the water with free energy. That's fantastic. However, the immersion's always halfway up the tank. It can never go below the coil, which means that you can only ever really store 50% renewable power in your hot water cylinder. So there's an area to be tackled there. The next thing is, if you've done your decarbonisation, you've installed either an air source heat pump or ground source heat pump, fantastic. Heat pumps are amazingly good at heating spaces. But when it comes to hot water, the efficiencies drop dramatically. We typically see, if you can get a heating system to run at a COP, coefficient of performance, just how efficient it is over the year, of 500%, when it comes to doing hot water, that can drop as low as sort of 180%. So it's a significant deficit. So air source and ground source heat pumps need all the help that they can get when it comes to hot water. Water is one of the cheapest energy storage technologies on Earth. It's cheap, it's safe, it's scalable as a storage medium. The problem until now is it couldn't think, it couldn't respond to tariffs, couldn't predict demand or capture surplus energy fully. If we look at the costings, a standard 300 litre cylinder can store 22 kilowatt hours worth of energy inside it. And for about £1,200, that's pretty cheap. For the same equivalent storage capacity for a thermal phase change material heat battery, that's £8,500. And for a lithium ion battery, that's £12,000. So there's a lot of potential here for hot water. And that's why we created the smart cylinder, a simple cylinder transformed into a thermal battery. The biggest difference between ours and standard cylinder is what we call destratification. We have a pump that sits on the outside of the cylinder, and it circulates the hottest water from the top down to the bottom when that bottom area is cooled. That means that the full volume of hot water is a consistent temperature. That means that your primary heat source, your gas boiler, your air source heat pump, your immersion element, kicks on far less because it's consistent. The next thing that happens with that is, by virtue of having a consistent temperature across the full volume, we can deliver double the rated capacity of the cylinder worth of hot water out of it. So a standard 300 litre cylinder will deliver about 450 litres of hot water above 40 degrees. With the smart cylinder, our 300 litre cylinder will deliver 600 plus litres of hot water for up to 50% less energy. That also means you can reduce the size of your cylinders by at least 20%. And it will also improve the coefficients of performance of the heat pump by 10%. So it's quite an impressive thing that we've managed to do with this tin can. It gets even more impressive when we integrate AI. So EnviroHeat's created an AI on board the cylinder, which can display useful information for the customer. So if you're a hotel, it will display how many baths and showers you can get out of the cylinder at any one point, and you can manage demand that way. So it's useful information for customers. The other thing that unlocks everything for this, following on from our friends at Q Energy, is the ability to have the cylinder as an energy storage asset. The smart cylinder can now be part of your wider ecosystem of energy storage devices. It's another battery alongside your existing battery. It can take that PV power, it can take the battery power when it needs to dump it in an area that's useful, and that can do the job better elsewhere. So when we think about that, we can also integrate with dynamic tariffs. So when energy providers are needing the grid to balance and they pay you to take energy, a hot water cylinder is able to charge, overclock itself, and store a lot of energy inside as useful hot water for later. So think about that in your business processes, having the ability to have AI integrated with it, useful information, and be able to store paid for energy right away. That'll make your primary heat source work less hard. The components in your boilers and heat pumps will last far longer because it's not working so hard for your hot water. And we've taken a simple tin can into an energy management device. And it could be the missing piece in your plans to decarbonize your buildings. An example of this, we saved one client £78,000 in their first year. They had 41 apartments that had existing electric immersion cylinders. There was no gas for the area, it was all electric. And we replaced those 4 cylinders, 4 air source heat pumps powering 4 smart cylinders, and we dropped the consumption by nearly half. Massive carbon savings and a financial saving there, which allowed them to have a 2.5-year payback. So that about wraps up the presentation from me. And yes, there's a little QR code there that you can scan, and you can watch the Claudette. Claudette did the PR for this one for that particular project there at Fargate House in Sheffield. So you can take a look at that at your leisure. But yeah, I'm very much open to any questions. And yeah, thank you very much for listening. Hopefully, it's getting us thinking about maybe hot water is something that we could take a look at and help decarbonize businesses in some way, shape, or form. So thank you very much.
Hi everyone, that was great. So we've got about 10 minutes now for some Q&A, and there's a number of questions we've got here for our presenters. So the first question I've got here is for Hayley. Hayley, what's the biggest area where buy-in's required in an organisation to deliver an effective low carbon strategy?
For us, we have a number of stakeholders, so our councillors, our operational managers, and obviously our operational staff who will be using the equipment. So when we are looking at our strategy around decarbonisation and around carbon neutrality, it's keeping those stakeholders informed and up to date with what we're planning. Having them be part of the discussions with regards to things that are needing to change, we're mentioning around adding solar PV, changing vehicle types, changing the way that buildings are heated, making sure that everyone is on board with that and involved in those discussions at an early stage is sort of really important for us to make sure that those implementations and those installations work well.
That's great. Thanks, Hayley. And if I may, the same question for Rahil. Rahil, what's the biggest area where buy-in's required in your organisation to help deliver your low carbon or sustainability strategy? Okay, I don't know whether we've lost Rahil, so I shall move on to another question. Hayley, if I may, just a second question for you. What would you say have been some of the biggest lessons you've learned to date as part of your work to help reduce your carbon footprint at Salford in your organisation?
We've been working towards this for a long time. So you know, at first it was very much on the energy efficiency side. So looking at small changes that we could make to the way that equipment's maintained, making sure it's operating properly at the right times that we're expecting it to, little changes around sort of operational times of equipment, etc. Looking at small energy efficiency changes like changing LED lighting, which sounds really simple, but it does actually save a lot of energy and a lot of cost. And by reducing the energy consumption, you know, you are reducing those costs, those revenue side costs on energy. And then we moved into sort of more the low hanging fruit as such, and then use that as a case to move into other types of energy efficiency measures. So then moving into sort of, you know, replacing windows, insulation, looking at roofs, and how we're managing our buildings, but also into solar PV and battery storage. And that's been really important for us in terms of reducing our costs, reducing our carbon, and making ourselves less reliant on the grid, and having less impacts from sort of energy pricing issues that you know, come down the line and happen occasionally, depending what's happening in the world at the moment. So yeah, I think sort of they're sort of the main things that we've been looking at, and the approach that we've taken over the years.
That's great. Thanks, Hayley. And now I've got some questions for our innovators. So the first one is for Q Energy and Joe. We've got one here. My contract doesn't end until next year. Can I install your battery now to save on energy costs, or do I have to wait to switch to your tariff first?
Yeah, absolutely. Great question. And you don't have to wait, is the answer. So we can install a battery straight away at your site, and you'll start to see savings immediately, regardless of your tariff. And some of the examples of the way that works are, for example, if you do have solar PV on your site, we can store that excess solar in the battery rather than just exporting it to the grid straight away. We can try to make sure that we use that excess energy at your site, or sometimes we can even make sure that we're exporting at times when you might receive a higher rate for that export than you otherwise would have done by using that battery and finding those peak pricing windows. But even if you don't have solar PV, you can still install the battery, and there are still benefits because we can avoid any peak time charges that you have. So using that battery to shift any demand away from those peak times. Plus, Q Energy is also what's known as a virtual trading party, which means that we are licensed, if you like, to use the battery to respond to signals from grid operators. So if they say, actually, we need more energy right now, please discharge your batteries, we can do that. Or conversely, if they say, no, actually, we've got too much demand on the network at the moment, we need to take load off of it, we can switch to run the site from the battery. So there are still ways to benefit from the battery, even if your contract doesn't end. And of course, then when your contract is ready to switch, we can switch you onto that smart tariff.
That's great. Thanks, Joe. Right. So we've got a question here for Luke at EnviroHeat. Luke, how can smart water systems help support my business, and can they be scaled or multiplied if needed?
Yeah, it's a great question. You can kind of look at the existing infrastructure of the business now and look at your processes. So these systems can be daisy chained together, and in plant rooms. So you can start with one cylinder. If you increase your processes, you can add another and another and another, and just sort of increase your ability to continue doing your processes. But at the same time, if your business, again, think of it like a battery. So if your business doesn't actually need a lot of intensive hot water, it's still a thermal battery that you can at least take energy from the grid when it needs to deliver that. And you can even sort of link these cylinders, not just for kind of hot waters, for showers, baths, or kind of cleaning process and things like that. You can actually pump it into your heating system, and we can do sort of buffer tanks and things like that can support for other processes. So, it's quite a flexible system that you can sort of integrate, across physical space, but also, across years, if you're staying in one site and, you're expanding. So yeah, it's very, very flexible.
That's great. Thanks, Luke. I think we've got time for a couple more questions. So there's another question here for Q Energy and Joe. What are the minimum requirements for my business and building to utilize smart energy tariffs? So what are kind of the criteria, I guess, to make for consideration?
Yeah, absolutely. So the first thing we need to look for is that you have a half-hourly meter or a smart meter, because we do need that that level of detail to understand your site's usage profile. We'd also be looking for a site that's using at least 300,000 kilowatt hours a year. So that's probably the minimum size that we'd be looking for. If your contract is ending in the next 18 months, that's absolutely the right time to start talking to us, so that we can have the discussions. We can start thinking about battery locations and how we procure that battery and where it goes and how it links into your existing system. So there is a bit of a lead in time, but yes, half-hourly smart meter, at least 300,000 kilowatt hours of usage in a year. And if your contract's ending in the next 18 months, great.
Brilliant. Thanks, Joe. And finally, you've got another question here for Luke. EnviroHeat. So if we don't have a cylinder in the building and we have a combi boiler or point of use water heaters, does that mean we can't have a cylinder installed?
Absolutely not. We've done many projects where the existing plant infrastructure has been, large boilers or large sort of instantaneous heaters. And if you're still looking to make full use of a system and provide a little bit more stability and reduce the demand on those instantaneous boilers, then yeah, absolutely, you don't need to rip out the old system and put a new one in. This can be added in, and you can convert combination boilers into what would act as a system boiler. It really is a case of inline, taking out a section of pipework, sticking a cylinder inside that middle bit, and then it continues on for the rest of the project. It really is that simple. So it just because you've got a kind of more traditional system in there doesn't mean that you can't take advantage of sort of dynamic hot water. So there's nothing stopping you from going down that path.
Great, thanks, Luke. So we've kind of run out of time there for Q&A, but just leaves me to say massive thanks to all our presenters today and to our audience for joining us. I hope everyone found it helpful. And there will be a copy of this available afterwards, which we'll share in due course. Thanks for joining us, and we'll keep you posted in due course of our next webinar. We're doing them roughly every couple of months. But equally, if anyone's got any suggestions for webinars in future or interested in any of the innovations or insights that were shared today, please do get in contact with us and we'd be happy to introduce you to people. Thanks very much.